everybody, this video is going to go through all of the questions from the review sheet. That way, if you didn't quite get something that we went over in class, or if we ran out of time before we got to a specific question, you can go back to the question that you want to see and view the answer here. For number one, we're given the statement, if I live in Albany, then I am a New Yorker. What we have to do is write the inverse, the converse, and the contrapositive of this statement. So here I have the inverse of the original statement, which would be if I do not live in Albany, then I am not a New Yorker. Remember, to get the inverse of the original conditional statement, all that you need to do is negate both the hypothesis and the conclusion. The converse would be if I am a New Yorker, then I live in Albany. Remember, to get the converse of the original conditional, all you have to do is switch the order of the hypothesis and the conclusion. And finally, the contrapositive, which you can think of as a combination of the inverse and the converse. If I am not a New Yorker, then I do not live in Albany. Once again, switch the order and negate both the hypothesis and the conclusion. Question number 2 asks us to write a statement that is logically equivalent to the statement, if two sides of a triangle are congruent, the angles opposite those sides are congruent. And we need to identify the new statement as the converse, inverse, or contrapositive of the original statement. Before we can write the statement that is logically equivalent, we should first determine what it's going to be, if it's going to be the converse, inverse, or contrapositive. You might remember from class that the contrapositive is always logically equivalent to the original conditional. That means that whatever the truth value of the original conditional is, whether it's true or false, the contrapositive will have that same truth value. Remember that the contrapositive is when you both switch the order of the hypothesis and conclusion, and you negate both of them as well. So here I have one example of the contrapositive. Everyone words it a bit differently. So just as long as you had the order of the hypothesis and conclusion switched, and you had both parts negated, you are all good. Mine here says, if two angles of a triangle are not congruent, then the sides opposite those angles are not congruent. Number 3 is asking us to write the definition of a linear pair of angles as a biconditional. So remember, biconditionals use the words if and only if. So here I have the definition of a linear pair of angles. Angles form a linear pair if and only if they are both adjacent and supplementary. Just make sure in your response you have adjacent and supplementary to make a linear pair. And just to illustrate that for you guys one more time, let me draw a diagram. If I say that this angle over here is 80 and this one's 100 degrees, there we go. So the two angles here in the diagram do form a linear pair because they are supplementary. 100 plus 80 is 180. And they are adjacent. They are touching each other, connected, right up next to each other. The angles share both a vertex and a side in common. This next one could be a bit tricky, so we're going to use the process of elimination in order to figure out what construction this is a diagram of. So answer choice A says the bisector of angle ACD. Well, angle ACD is this angle right over here, and that's clearly not being bisected. We don't know anything about angle ACD. So I'm going to go ahead and cross that one out. That one is not the correct answer. The midpoint of DF. So although it might be true that C is the midpoint of DF based on the construction here, we didn't learn about any constructions called the midpoint construction. We learned how to find midpoint with a formula. We learned how to do some other constructions like perpendicular bisector to find a midpoint, but we didn't talk about a midpoint construction. So I'm going to get rid of that choice here. Oh, end of DF it says. So that's also why that answer choice is incorrect, because it says the midpoint of DF. So this construction doesn't tell us anything about DF. This construction is doing something to segment AB. C says the perpendicular bisector of AB. That sounds reasonable. And D says a perpendicular line to AB from point D. That sounds reasonable as well. The answer actually is the perpendicular bisector of AB. If you look back in your constructions packet that you were handed in class, and if you don't have it anymore, it was uploaded on Google Classroom under the classwork section. The perpendicular line construction has another arc to start with. Very small difference, but this is the perpendicular bisector of AB. That's the construction here, not perpendicular line from point D. For number 5, the first thing that I'm going to want to do to approach this question is to mark my diagram and maybe use some different colors. So we're told that ray QT is perpendicular to angle PQR. So I know that the ray is making 90-degree angles where it intersects angle PQR. So that's important for us to know. We also know that QW, ray QW, where is that? Right over here, is perpendicular to ray QS at point Q. So we have another right angle in here, very important. And the measure of angle SQP is 25 degrees, and they already filled that in for us. They were nice to us. They filled that in the diagram for us already. What we need to find is the measure of angle TQW. So that would be TQW, this angle right over here. I'm going to put a question mark here because we need to find it. So in order to find the missing angle TQW, we're just going to use the fact that we have right angles going on here. So I know that this angle here is 25 degrees, and I know this angle plus this angle should make a 90-degree angle in total. So let's do 90 minus 25 degrees to find the measure of angle SQT over here. And we get the measure of angle SQT is 65 degrees. We can use the fact that angle SQT and angle TQW add up to be 90 degrees in order to find the angle TQW, which is what we're interested in. So let's do 90 minus 65, and we should get the angle here. And that makes this 25. Let me put that in. We do it in green, 25 degrees. So we have the measure of angle TQW is in fact 25 degrees. For number 6, we are told that angles 1 and angle 2 are supplementary to each other, and we need to find what angle 3 is. So let's use some of our angle relationships here. First of all, this 35-degree angle and angle 1 are also supplementary because they form a straight angle altogether. So we can find angle 1 by doing 180 minus 35 degrees. And that will give us 145 degrees. Let me put that in over here. Now, since angle 1 and angle 2 are supplementary to each other, to find angle 2, all I need to do is 180 minus 145, and that should give me what angle 2 is. Let me write that here. That is 35 degrees. And now to find out the measurement of angle 3, angle 2 and angle 3 are vertical angles. They come out of the same point and they're non-adjacent. They don't touch each other. So we call those vertical angles. They look like they're opposite from each other. Vertical angles are always congruent. So if angle 2 is 35 degrees, angle 3 is 35 degrees as well. And we have found the measurement of angle 3. In this question, we're told that the measurement of angle AED is 152 degrees. Let me go ahead and put that into the diagram to begin with. And first we need to name the vertical angle pairs and the adjacent angle pairs. So vertical angle pairs, let's do that first. I'll abbreviate that as VA. So angle AED and angle BEC are vertical angles. And also angle AED and angle BEC are vertical angles. If you check it out in the diagram, AED, this one over here, and BEC, this one here. These two are in fact vertical angles. And AEB is right here, DEC is right here. Those are in fact vertical angles as well. Now for the adjacent angles, let me abbreviate that as well, and I'll do that in blue. So angle AED is adjacent, so that's this angle over here, and that's adjacent to this angle here, angle AEB. But angle AED is also adjacent to angle DEC. Let's keep going. Angle DEC, this one over here, is also adjacent to angle BEC. And angle BEC is also adjacent to angle AEB. And there we have it. We have all of the adjacent angle pairs in this diagram. The last thing we need to do is to label all of the angles here with their measurements. So since vertical angles are congruent, angle BEC should be 152 degrees as well. And to find the other two angles, since this angle and this angle are supplementary and this angle and this angle are supplementary, let's just do 180 minus 152 degrees to find the missing measurement for both of the angles. Both of the remaining angles are going to have the same measurement because they are vertical angles, which are always congruent. And I got 28 degrees for both of these angles. For number 8, we're going to find in radical form the length of the line segment joining points 1, 5 and 3, 9. I'm going to start off with writing my distance formula down on my paper. Once I have my distance formula down on my paper, I'm just going to label the points. So I'll call this one x1, so then by default this one y1. This one has to be x2 then, and this one has to be y2 then. So let's go ahead and plug into our formula. So x2 is 5, we labeled that, and we labeled x1 as 1. y2 we labeled as 9, and y1 we labeled as 1. All I have to do now in the next step is simplify. 5 minus 1 is 4, 4 squared is 16. 9 minus 1 is 8, 8 squared is 64. Now get your calculator out because you're going to have to add 64 and 16 together, and you should get 80. So the question didn't say in simplest radical form, it just said in radical form, but you can go ahead and simplify if you want. However, if you're not completely 100% with simplifying radicals, I do recommend that you stop here at this step and write this down as your answer because this will give you full credit and it is the exact value of the length of the line segment that you're looking for. For those of you who want to take it a step further and simplify it completely, radical 80 breaks down into radical 16 and radical 5. The square root of 16 is 4. So we have 4 radical 5 as our answer in simplest form. But once again, if the question doesn't ask for your answer in simplest form, you don't have to simplify it. Radical 80 would have been just fine in this situation. The only thing you should not do is take your radical, put it into the calculator, and write down all of the decimals that you see. That's rounding because radicals that don't simplify to whole numbers go on forever and ever and ever. So if you round when the question didn't ask you to, it's actually considered a rounding error and will be points off both on tests and on the Regents exam. For the next question, we're asked to construct the bisector of angle ABC. So the first step whenever you're bisecting an angle is to put your compass on the vertex of the angle that you're bisecting. Let me give myself some more space and let me turn my compass around so I can get a better grip on it, better virtual grip, I should say. So I have my compass on the vertex of the angle that I'm bisecting on vertex point B, and I just want to open my compass. It doesn't matter what distance I open it to. I'm going to make an arc, and the only thing that matters, oh no, my whole paper moved. The only thing that matters is that the arc hits the angle in 2 spots. Oh no, why is it not writing anymore? Technical difficulties, there we go. So I have my arc, and notice how it does intersect the angle. in two spots, here and here. What I'm going to do next is I am going to take my compass and put it on one of those two intersection points. And I'm going to open my compass. It doesn't matter how much I open it. The only important thing is that whatever I use here to make this arc, I keep the same measurement when I turn my compass around and bring it over to the other intersection point here. I want to make sure that I do the same arc. That way I am, in fact, cutting the angle directly in half. So that point of intersection of the two arcs is where I'm going to draw the bisector through. So let me get a line here, and I'm going to start at the vertex of the angle. Oh no, let me try that again. So I'm going to start at the vertex of the angle. Why does it keep doing that? One more time. I keep pressing the wrong button on my computer. Okay, so I'm going to start at the vertex of the angle, and I'm going to extend my line right through the point of intersection of the two arcs. And that should be really, really close to splitting the angle exactly in half. Remember, our goal is to be as precise as possible. We're not going to be 100% because we're doing this by hand, but it looks really, really close to cutting the angle exactly in half into two congruent parts, like a bisector is supposed to do. Now we're going to find the measurements of two supplementary angles that are in a ratio of 7 to 2. So let's do it. Whenever we have a ratio, we can represent the larger one as 7x because the larger part of the ratio is 7. And we can represent the smaller angle as 2x because 2 is the smaller part of the ratio. And we know that the two angles together need to add to 180 degrees because they are supplementary, and that's what being supplementary means, that the angles add to 180 degrees. So let me set up my equation that says exactly that. If I take both of the angles and add them together, their sum should be 180 degrees. Now let's combine like terms and solve for x. 7x plus 2x is 9x. That's equal to 180 degrees. Now we're going to divide by 9 on both sides, and we get that x is equal to 20. So we found our x value, but the question is asking us for the measure of the larger angle. So the larger angle is the 7 part of the ratio, the 7x part. So I'm just going to substitute the x value that we found into that expression 7x. So 7 times our x value is 20 gives us 140 degrees. So that would be the measurement of the larger angle. For number 10, we are told that we have the length of the hypotenuse of a right triangle. So I'm going to start by just drawing my right triangle so you guys can see this visually. So the hypotenuse is opposite the 90-degree angle. So we know that that's 13 centimeters. And one of the legs, it doesn't matter which one, is 12 centimeters. And what we need to do is find the number of centimeters in the length of the other leg. So this is an example of a time where we can use the Pythagorean theorem because we do have a right triangle. We have information about two of the sides of the right triangle, and we want to solve for the missing side. So let's do it. Remember that the Pythagorean theorem is a squared plus b squared is equal to c squared. C represents the hypotenuse. So in for C, we need to plug the 13. A and B represent the legs, and it doesn't matter which order you plug them in for. So we just need to make sure that we put 12 in for either A or B. Let's put it in for A, and then we'll be solving for B. So let's do it. Plugging in the 12 for A, we have 12 squared plus B squared. We don't know what the second leg is equal to 13 squared. 13 is the hypotenuse. Let's simplify this a bit. 12 squared is 144, and 13 squared is 169. Next, to continue solving, let's subtract 144 on both sides, and I get that b squared is equal to 25. Take the square root of both sides, radical both sides, and we get b is equal to 5. So the missing side of the right triangle is, in fact, 5. So I'm going to write that here on the top and box it, 5 centimeters. That's the missing leg. This question over here is asking us to construct a congruent angle to the one that we're given. So let's do it. So I want angle BAC to be congruent to angle DEF, but I only see line segment EF, so that means that we have to actually copy this angle from here to here and create angle DEF through construction. So let's do it. The first step for copying an angle is to put your compass point on the vertex of the angle that you're copying. So here that would be vertex A. I'm going to open up my compass. It doesn't matter how much. All that matters is that when I make an arc, the arc intersects the angle in two spots. Using the same distance, or the same hole if you're using the red compass, I'm going to go over to the line segment where I'm creating the copy of the angle. With my compass point on the vertex, I'm going to make the same exact arc. We call this the reference arc, and we call it the reference arc because we're going to use it in order to measure the angle that we started with so that we can take this measurement and put it over here to make a congruent angle, to copy the angle. So notice that we had two places where the reference arc hit the angle here, and we had one place where the reference arc hit the angle here. I'm just going to darken it just to make things a little bit easier to see as we go along. Next, I have to actually measure the angle. So what I'm going to do is I'm going to measure from this top blue intersection point to this bottom blue intersection point. And it's a little small, so it's a little bit difficult to do this on my end over here. So I'm going to take my compass and put my compass point on one of those blue intersection points. I put it on the top one, and then I'm just going to open my compass to the other blue intersection point, and that's going to give me the measurement of the angle, how big the angle is. And I'm just going to make an arc just to show that I measured. And as you can see, I'm not 100% perfect. I try to be as precise as possible since I'm using this electronic compass and all, and the diagram's pretty small, but we try to be as precise as we possibly can, but we're not 100%, as you can see. That measurement was not 100%. So now using that same measurement I just measured, I'm going to pick up my compass and move it over to the intersection point here. And what I'm going to do is I'm just going to make an arc using the same length that I had measured before. Now I see that there is a spot where my two arcs intersect. And through that intersection point, starting at the vertex, is where I'm going to draw my ray. We can, oops, I keep clicking things. We can pick a point on the angle and we can call it point D. And now we have angle DEF, and it is congruent to the angle that we started with, angle BAC, because we did copy this angle and put it over here. This question tells us that two angles are complementary. Recall that complementary means that the two angles add to 90 degrees when you add them together. The measure of one angle is 15 more than twice the other, so that's the bigger angle. So the smaller angle, I'll just write it over here, let me get my pen, it's going to be easier. The smaller angle, let's represent as x. And the larger angle, since it's 15 more than twice the other, I see some keywords here. 15 more, that means addition by 15. So it's plus 15 more. And it's also twice the other. So it's 2 times also. So we have a multiplication by 2 and we have addition by 15. So we're going to be multiplying that x by 2. That's twice the smaller angle. And adding 15. That's 15 more than twice the smaller angle. Wonderful. These word problems are a bit tricky. We just have to figure out what the question is saying and use that to represent our angles. Now, all I need to do is set up my equation that says the smaller angle plus the larger angle should equal to 90 degrees. So we have x plus 2x plus 15. Add up both of those angles. Should be equal to 90 degrees. Combine like terms, we have 3x plus 15 is equal to 90. Subtract 15 on both sides. 3x is equal to 75. And then finally, Our last step here, in order to find our x value, is to divide by 3 on both sides. And we get x is equal to 25. Now we have our x value, but the question asked us for the measure of the smaller angle. Well, we represented the smaller angle as x. So our x value of 25 is the angle measurement of the smaller angle, 25 degrees. And finally, this question is just asking us which diagram shows the construction of a 45-degree angle. First, think about how we can get a 45-degree angle. 45 is half of 90 degrees. And we talked about how we can construct a 90-degree angle by constructing a line that's perpendicular to the one that we started with. So if we can construct a 90-degree angle with a perpendicular line construction, how can we then get a 45-degree angle? If you were thinking that we cut the 90-degree angle in half because 90 divided by 2 is 45, you are exactly right. And remember, our construction to cut a 90-degree angle in half, to cut any angle in half, is the angle bisector construction. So we are looking for the angle bisector construction done on a 90-degree angle. So let's take a look and let's see which one has the correct construction. So the answer here is angle C. I'm sorry, choice C. From choice C, you can see that we're starting with a 90-degree angle because the construction marks are here. Over here, I'll just trace them for you. So these are the construction marks from constructing the original 90-degree angle. And if you're a little bit confused on that, see your constructions packet. It's also posted on Google Classroom for perpendicular line through a point. That creates a 90-degree angle. It's a perpendicular line. And then the other construction marks, the first arc and then the other two arcs using the same length or the same hole, are the angle bisector construction marks. So C is the correct construction of a 45-degree angle. Start by constructing a 90-degree angle and then bisect it. Just as a reminder, check out the digital foldables on Google Classroom for important vocabulary words and formulas. There's a bunch of resources on Google Classroom. In fact, under the extra practice section, there's also like a second review sheet, kind of. It's optional, but it's more practice on questions similar to those that will be on your test. You might want to check that out as well. Answer key is posted for that. And please review all the constructions that we've learned about. We've learned about copying a line segment, copying an angle, bisecting a line segment, bisecting an angle, and constructing a perpendicular line. Those are all the constructions from the construction packet, except for type 4, parallel line constructions. We're not seeing that one until after the first test. Please also make sure that you know your formulas. There's only 2 formulas that we really talked about so far, the distance formula and the midpoint formula. So please make sure that you do know those 2. Thanks for watching and good luck on your test, everybody.